Okay, so now we're in Chapter 4, and in Chapter 4, we're going to be looking at discrete probability distributions and combining some of the ideas we saw in Chapter 2 with some of the ideas we saw in Chapter 3. So the first thing we need to do is get a few new definitions. The first one is the definition for a random variable. A random variable is a numeric value associated with each outcome. They're denoted by x, and for example, x could be the number of sales calls a person makes, or x could be the hours spent on sales calls in one day. Notice there's a slight difference between those, even though we're essentially talking about the same thing, we are distinguishing them in slightly different ways, which is going to be important. The discrete random variable has a finite or countable number of possible outcomes. The random variable is discrete if what you have to do is count the outcomes. For example, we count the number of sales calls a person makes. Whereas a continuous random variable has an infinite number of possible outcomes. With continuous random variables are distinguished by the characteristic that we measure them. In fact, we measure time, so that if x is the number of hours spent on sales calls, we measure that, which makes it continuous. Let's look at an example and decide the number of Fortune 500 companies. Do we count those or do we measure those? Well, you count the number of anything, so that makes it discrete. The volume of gasoline, do we count volume or do we measure volume of gasoline? Well, we would measure it, which makes it continuous. Now, from now on, in the rest of this chapter, we're only going to be looking at discrete probability distributions. In discrete probability distributions, we're going to list each possible value together with its probability. So, in other words, remember from probability, all probabilities have to be between 0 and 1. So the probabilities in a probability distribution must also be between 0 and 1, inclusive of 0 or 1. And the sum of all the probabilities has to equal 1. So how do we construct a discrete probability distribution? Well, the first thing we do is make a frequency distribution. Then we find the sum of the frequencies. Then find the probability of each of these possible outcomes by dividing frequency by the sum of the frequencies. And then check that each probability is between 0 and 1 and that the sum is 1. So for example, here we have a personality test, and it was given to 150 different employees, and 24 of these employees had a score of 1, 33 employees had a score of 2, and so forth. So let's construct a probability distribution for this random variable. Well, the first thing we need to do is find the probability of achieving a score of 1 using what we saw in Chapter 3 is known as the empirical approach to probability. And there was 24 people out of the 150, or in other words, the probability of getting a score of 1 is about 16%. So on for the probability of getting a 2, 33 people got a 2 on the exam out of the 150. 42 people out of the 150 got a score of 3. In other words, about 28%, and so forth. Then you just make list it out as a table. Here are all the possible values that you could have gotten on that test and their respective probabilities. This is a discrete probability distribution. This is set up in table form, and we can also set it up as a histogram, which you'll see in just a minute. Let's check that this is a valid probability distribution. Are all of these numbers between 0 and 1? Yes. If we add them up, they should sum to 1, and they do. And here's another way of denoting or expressing a discrete probability distribution using a histogram, where the height of each of these bars corresponds to the probability of getting the score of 1. This stands for the probability. This height up here stands for the probability of a score of 2. To find the mean of a discrete probability distribution, you multiply each of the values times their respective probabilities and then add them up. So for example, 1 times 0.16, 2 times 0.22, 3 times 0.28, 4 times 0.20, and 5 times 0.14, and we get these numbers here. Add them up, they sum to 2.94, which is the mean or the average score on this test. To find the variance or the standard deviation is a little more complex, but we're still going to set it up like a table. So what we're going to do is first do 1 times 0.16, right, to find the mean, right? So we found the mean is 2.94, sorry. And then we do value minus mean, 1 minus 2.94, 2 minus 2.94, 3 minus 2.94. We get these numbers. Then recall the formula had us squaring those numbers. So you take negative 1.94 squared, negative 0.94 squared, and get those values. Then times this number times the probability, so 3.764 times the 0.16, 0.884 times the 0.22. Then we sum this up, we get 1.616, which is the variance, and recall the standard deviation is the square root of the variance, and the square root of 1.616 is approximately 1.3. Expected value is just another name for the mean, so it's the exact same formula. Expected value is the mean, which is x times p of x, and then sum them up. So for example, suppose you want to find the expected value or the expected gain for a raffle. Now they sold 1,500 tickets at $2 each, and there were 4 different prizes. Now notice, if you won the $500 prize, you did not gain $500 because it cost you $2 to play the game. So your gain was $498. Also, if you won the $250, your gain was only $248. Likewise with these other 2 gains. But if you did not win at all, you did not come out, your gain was not 0, your gain was a negative $2 because you lost $2. So let's find the expected value, which is the same thing as finding the mean. We could set up the table here like this. Excuse me. And we could do, and we just do 498 times the 1 over 1,500, 248 times the 1 over 1,500, right? And then sum each of those values up, and we get a negative 1.35. So you can expect to lose an average of $1.35 for each ticket you buy, which is what it's expected because the church or the group, the club that had the raffle expects to make money. They expect you to lose and them to come out with a net gain that's positive. That's the end of section 4.1. Now please go to the My Math Lab at the Course Compass website and do the homework set for 4.1.